Hi everyone, welcome to another linear algebra tutorial. In this tutorial, we'll be learning how to solve system of linear equations using matrix notation. So in this tutorial, we'll be learning how to express solutions using vectors and hence vector notation. So these five systems are the systems that we'll be covering for today's tutorial. Let's go into detail. The first equation. So this is our first system. So now let's do the first step. The first step is to abbreviate this linear system with this matrix as shown over here. So after this, the same thing. So just imagine that it is a system. So we want to eliminate the x variable on the second row. But you notice that the first row has a higher coefficient of x. So we swap row 1 with row 2. Hence we get this form. And after this, we can eliminate the x variable easily. So we add minus 3 times from row 1 to row 2. We get this. So the left hand side will go as this again. And you do this until you get 0. So there's no variables. And the right hand side will go to 0 as well. So hence this means that there's no variables on the second row. So now we identify the leading and non-leading variables. So what's the leading variable? It is x. And the non-leading variable, y. So now that we know the leading and non-leading variable, we can tell that the system has many solutions because it has at least one non-leading variable. So last step, we write the leading variables in terms of the non-leading variables. So we know that y is a non-leading variable, and from the first row we can see that x plus 2y equals to 6. So we express x in terms of y. So therefore x equals to 6 minus 2y. So we write again. So x equals to 6 minus 2y and y equals to y. So in vector form, it is written as this. And as you can see from here, we can actually write the vector notation. So x minus y equals to xy equals to 6, 0 because there's no constant here. So minus plus minus 2, 1 and then y. So y is the free parameter. So when you expand this, is x equals to 6 minus 2y, which is this, and y equals to 0 plus y, which is this. So this is how we do it. So now for the second example, it's the same thing. So now, first step is the easiest, abbreviating this linear system with this matrix as seen as this. So now, second step, you want to eliminate x variable in the second row. Hence, we add minus 1 times of row 1 to row 2. So this is the left hand side of how we do it for the variable. So you get minus 2y, and the right hand side is minus 2. So you get written as this. So yes, the second row has y variables. So it's written as this. So the step, identify the leading and non-leading variables. You notice that this system has only leading variables and no non-leading variables. So hence we write the leading variables is x and y, and the non-leading variable as there is no. So this system has only unique solution. So hence we write from the second row, we can see that minus 2y equals to minus 2. So hence y equals to 1. And plugging it into my row 1, we get x equals to 0. So expressing in vector is a solution set with one element. So hence it's written as this. And the notation is also written as this. So now let's carry on with our third example. So our third example is this. Notice that this example has 3 unknowns and 3 equations. So not to fret, do the same thing again. We abbreviate this linear system with this matrix. So this is what we get. And now you want to eliminate the x variables on the second and third row. So these are the steps again. I won't say the steps. Add minus 1 times of row 1 to row 2 and add minus 4 times of row 1 to row 3. And this is how it works on the left hand side and right hand side. I will not go into detail all this. So after this, you want to eliminate the x2 variable on the third row. So same thing, add minus 1 times of row 2 to row 3. And this is how it happens for the left hand side of the equation and right hand side. You can take a look at this again after I've finished this tutorial. So hence, their third row has no variables, and hence it's written as this. So now, we identify the non-leading and leading variables. So what are the leading variables? x1 and x2. Non-leading variables is x3. So now, since the system has at least one non-leading variable, therefore the system has many solutions. So now we write the leading variables in terms of the non-leading variables. So now we know that x3 is the non-leading variable. From the second row, we get this, minus x2 plus x3 equals to 1. So we express x2 in terms of x3 as here. And now, from the first row, we can see that x1 plus x3 equals to 4. Hence, x1 is expressed in terms of x3 as seen here. So now, we write again the form for x1 to x3. And now, using vectors, we write x1, x2 and x3 expressed in this form as this. We just put the bracket over it. So now, in notation, it's the same thing. So now, you separate. So now is 4 minus 1, 0 plus minus 1, 1, 1, x3. So when you expand it, is x1 equals to 4 minus x3 and x2 equals to minus 1 plus x3 and x2 equals to x3 as seen here. So now for part D, we are given this. So same thing, we abbreviate this linear system with this matrix. So now you notice that the bottom row has a lower coefficient of x. So we swap row 1 with row 3 and we got this. So now we add minus 2 times. You want to eliminate x variable. This is what we do. I won't go into detail again. And these are the workings. Hence, we get into this form. And now you want to eliminate the b variable. Hence, we add minus 3 over 2 times of row 2 to row 3. And the working is all here. You can take a look at it later. We get this. So now, you notice that, so now we identify the leading and non-leading variables. We notice that there are no non-leading variables and there are leading variables. Therefore, it has a unique solution. And hence, from the third row, you get c equals to 1. And from the second row, you plug it in, you get b equals to 1. And from the first row, you get a equals to 1. So this is how it's written. One solution set with one element. So let's go into detail the last example. The last example is different. I'll tell you why. Okay, so now in this case, you have 4 unknowns and 3 equations. We do the same thing first. We abbreviate this linear system with this matrix. And now, you notice that the bottom row has a lower coefficient than the second row. What do we do? We swap row 2 with row 3 and we got this. So now the same thing, you want to eliminate the x variables on the second and third row. So we do these steps and we got this. And now you want to eliminate the y variables on the second and third row. So hence we do this step. and you obtain something like this. And as you can see, the bottom equation is redundant. It's logic and yet it's redundant, so we just leave it. So now the second last step, we identify the leading and non-leading variables. So what are the leading variables? X and Y. The non-leading variables, Z and W. So now we already can tell that the system has many solutions since it has at least one non-leading variable. Hence now we write the leading variables in terms of the non-leading variables. So from the second row we got this. So now we write y, we express y in terms of z and w. We get this, which is y equals to 2 over 3 plus 2 over 3 z plus w. And for the first row we get this. So we express z in terms of z and w. We get this. We have this. So now we write x, y, z again. And in vector form, we get this and this, which is just direct from this. And now the hardest part is the vector notation. Since it has two non-leading variables, therefore it has two free parameters. And these are your constant here. And the parameters, we separate them. Like what we do now, x, y, z, and w, we get this plus this plus this. But you want to make it to, so we can also express it in this way. So equals x, y plus z plus w equals to 1/3 minus 1, 2, 0, 0 plus, we change the variable, so instead of z we get lambda, so we put lambda as z over 3, so we present it in this form, and this will still be constant, and hence this will be our final solution in vector notation. That's all for this tutorial.